Hello everyone, this is the 14th episode of Hydra Book Reading Club series, and in this video we're going to finally dive into GLSL, well, creating custom GLSL functions. Okay, um, and if you go to Hydra Book, I think I skipped feedback, but this was actually not in the original Hydra book. I added this page later based on some things I talked in the tutorial videos, and I think I've already explained a lot. This is not saying that which is advanced or less advanced, but this I kind of talked about a lot in the intermediate tutorial, so I'll skip this page. If you think this is super useful to revisit again as Hydra Book Reading Club, I will definitely do it. Please comment down below in the comment section. But for now, I will just like skip this one and go to custom GLSL. And I was quite optimistic. I thought like, okay, if I put just a disclaimer that this is only for people who already know GLSL, because this video is not really intended to talk about how GLSL works. So as a prerequisite, sorry if you're not familiar with GLSL, I'll try to like explain as much as I can, but I'm not gonna like talk about the very basics because it's quite overloaded topic in itself. And like how does shader work? That's another whole like body of like work. So I'm not going to talk about it, although it's really helpful. Like if you're really curious about it, I highly recommend digging into like how GLSL shader works, like computer graphics work. It's just like super interesting, and you might start to have like another understanding of Hydra, because Hydra is basically based on like built on top of shader. Like GLSL is one like implementation of shader, and it would really help, although you don't need to know how shaders work to use Hydra, and that's the beauty of Hydra and live coding, I guess. But in this video specifically, because we're gonna like really going into like low level of Hydra to create your own functions, tweak existing functions. So that's that. But still, actually, there's quite a lot of things that I need to explain. I just noticed that it's not as simple as I expected when I went through some examples. And I'll actually need to like add so many things before going through the Hydra book, because I think I'm assuming a lot of things in here, and I didn't really talk about how Hydra uses GLSL and how these like function chaining works with GLSL. So there's like actually like only like a few things that you need to know in order to like start doing this. Besides all this knowledge about GLSL, I mean, okay, so that's not like that's part of it. So again, it's really complicated topic, but if you're just like curious, I'll try to like explain in this video as much as possible. So maybe you can just go through the video, and if you find it interesting, maybe you can find more resource to understand it. I hope this will be like an interesting starting point, but it's not like a comprehensive tutorial. That's what I want to say. And I would say like there are like only like two things if you really just want to like tweak parameters. One thing is that you have to use this set function, which is a little bit like, okay, let's go to the editor, and so I just deleted the code, but this is one of the examples from Olivia, and this is basically the Hydra code we are like familiar with, right? But also there's kind of like meta functions. Well, I just made up that word, but like for example, render function. That is like, it's part of Hydra, but it's not really generating Hydra code, right? And I just go back to render old 0, or what else? Set resolution. I'm not gonna like evaluate this because then things will change. But for example, this is like comes with Hydra, but it's not really like generating images, although it affects the image. And there is another one that I didn't explain, which is setFunction. And what setFunction does is that it's actually used inside Hydra itself to kind of define all the functions that are like used or prepared by Hydra. For example, OSC, Kaleido, color, rotate, modulate, all these functions, everything is defined with setFunction, or can be defined with setFunction. And if you go to this Hydra book, you can find this link, custom GLSL page, the very first paragraph is built-in functions. If you click on this, it will just go to the source code of Hydra. It's part of Hydra itself that is used inside Hydra library. It's JavaScript, valid JavaScript code. And this is basically kind of like a dictionary, but also like it has all the recipe of Hydra functions like OSC, Voronoi, well, here's noise. And if you're curious like how actually noise function works, then this is where you should look into, because it actually defines how noise works and how noise function generates GLSL code that will be compiled by GLSL compiler and generate visuals. So this is like taking care of like all these things under the hood that you don't really need to know, but if you really want to dig into it, if you really want to create custom GLSL or like custom functions, this is where you have to start. And the indentation is a little bit funny, so you have to like decipher a little bit sometimes. But let's take our favorite, well, maybe OSC is not the best, not the easiest example. Let's say gradient. Okay, this is, I think it's a really good one. So if you take a look, don't be like fooled by this backticks. Backticks are also really confusing. I think this curly brace, curly bracket ends here. So I'll just copy it. And what setFunction does is that, well, what it takes is basically this whole object. And is it a JSON object? It can be also, because it's not really, it has a code inside, but it actually not JavaScript code. It's different from like this arrow function, anonymous function kind of thing, but it's actually just a chunk of string that will be used inside shader to be like compiled as a shader. And we can just like go through like line by line. Name, gradient, which I will just change it now immediately, because before I forget, because what happens if you keep the same gradient and if you start changing the code, it will overwrite existing gradient function, our favorite, well, maybe not the favorite, but our friend, definitely, gradient, let's say, out. So let's just like evaluate this code. This is what we know, no surprise, right? If this is surprising to you, probably you should go to like beginner's tutorial or intermediate tutorial, and then you can come back. But also like, you can just like watch it as it is. So what happens here, like if I start to change something like, okay, I don't know what this st is, but multiply by 2 and evaluate everything, then oops, that's not good because it has to be 2.0. Now, this is also something I need to do, especially for this GLSL tutorial, is that I'm going to open the developer console here. I did Command Option I. You have probably like different shortcut depending on the operating system or browser. Normally it's in the menu like Tools, Developer, whatever. You can find the developer tools. And I just open it because unlike Hydra code that like if you have some kind of syntax error here, it will say unexpected token at the bottom. But of course, if you have something like significantly wrong here, then it will report the error. But if there's an error inside GLSL function, I can also say like, and just compile it. It will not say any error here. And then as soon as you compile or like evaluate the Hydra code, it goes wrong. I just like erased it and evaluated everything, so now it's back to normal. But it's kind of silent in the console here. But in the developer console on the right, you can see that there's WebGL warning link program must have a compiled fragment shader attached. So there's like some kind of warning is there, which indicates that something is wrong with the GLSL. But JavaScript compiler and GLSL compiler, they are different things. So actually Hydra doesn't know that shader did something wrong, because normally we don't touch this set function, or inside GLSL code, we don't touch this. So Hydra doesn't need to tell you. But if you're going into this kind of, so it's like a danger zone we're like entering. And in this danger zone, you might encounter these weird things, especially like when it's flickering. Okay, something is wrong with the GLSL. You should open the developer tools and check if there's GLSL, well, no, WebGL warning inside. Now, what did change? I added this times 2.0, and also like this is something funny with GLSL. If you code GLSL already, you probably know that times 2 doesn't work in this case. It has to be times 2.0, but also depends on the version of the GLSL or what kind of shader you're using and so on. But now I have to be really careful that always put 0.0. So it's not integer, but it's floating number. Now, what I wanted to say in this very basic example is that I have this gradient that is like already overwritten. If I put it back to normal, you see the color changed quite a lot, because now I was like amplifying red and green channel. So if you break this down, you have this like vec4, and basically underscore st is the coordinate. Okay, so there are like so many things. So from now on, I'm gonna say like this is like gradient 2, because I don't want to change the original gradient. I want to experiment in a space where it's like safe. Of course, like it's not gonna like override like Hydra code base. So if you refresh the page, it's gonna be fine. If you break everything, you just refresh the page, it should be fine. But for the testing, it gets like confusing if I start like override OSC with gradient or gradient with Voronoi and so on. This is not like, maybe if you are really into like esoteric language, that may be like interesting thing to explore. But in this case, I want to be clear about what is happening. So I'm not gonna like overwrite the gradient anymore. It's actually not protected per se. Like it's like you can like really change the gradient code if you want to, if that's what you want. But that's not like for illustration in this video. It's not what I want. So I'll put gradient 2. So that the original gradient is safe. And now here what happens is, I'm gonna just like explain like what this GLSL part is doing. Since we took, okay, so there are like also like so many things like preamble I need to add. Now we're talking about gradient. Gradient is a source. Like if you go to this API page, you remember there are like different categories like source, geometry, color, blend, modulate, and more. But this basically these 1, 2, 3, 4, 5 are the ones that we are interested in setFunction. That's how setFunction, like all these functions listed here are defined in this list of like objects and passed to setFunction to be used inside Hydra. And basically that's like we said, like there's 5 categories like source, geometry, blah blah. So we have to tell setFunction which kind of category of function are we talking about. And since gradient is a source, it's a type SRC. It's kind of confusing because there is actually SRC source as well, but it's like a more convention. It's really like sometimes really confusing, but it's also like not something that you would touch normally. So probably that's why it's kept like more like a historical reason that it's called SRC instead of source. And the next one is the inputs. And this is quite an interesting one, but also I'm not gonna like talk about it so much today because like this is more like a design you can do. Like if you want to like create these functions to be like really like used extensively by yourself, by others, then always like this inputs, these are the parameters that Hydra takes. So for example, in this case of gradient, or now the new gradient 2, we have this floating, like float number as a one input, and the name is called speed, and the default parameter is 0. And default parameter is probably like easiest one to like explain. So if I change from 0 to 1, what happens here is, okay, not gonna work with gradient anymore. Now we're talking with the gradient 2, and evaluate all, and you can see that even though I didn't set any parameter here, now it's like behaving just as gradient with the parameter 1. I mean, that's the whole thing that this default is about. And you can always override this default value by adding your favorite argument. That's how it works with like OSC and so on, right? OSC always comes with 60, but if you don't like OSC 60, then you just put like OSC 10 or OSC 1 or OSC 120. But this default value is defined here. And I deliberately chose gradient because it only takes one input. But if you take, for example, OSC, we can like just have a look at it. Here, this one is OSC, and it takes 3 inputs, as we know: frequency, sync, and offset. Sync is a speed, right? And it's always, so I talk about OSC 60, 0.10, which are defined here. And inputs can be like really long. Like we usually have like inputs up to like 4 inputs, I think, in Hydra. But, or like, can be 0, like no input, or it can be like 1 input, 2 input, 3 input, 4 input, like scroll, for example, like combined X and Y. It can take, first one is X, second one is Y, third one is speed X, fourth one is speed Y. Sorry, I'm going backwards all the time because my image is flipped. But anyways, so this is like where this input is defined. But if you want to have like 100 inputs for this gradient 100, then that's also possible. I don't know if that's useful or not, but if you want to make it, that's possible. But I'll just keep it like as it is for now because it's not so important for me like to actually design a function. It's more like I'm interested in the GLSL code itself, and I'm not gonna like kind of open source this. Well, I mean, it's open, but it's not like I'm going to make a new library. Then I really have to design what the inputs are. But if you're just like experimenting, you can just like directly change the GLSL code, so you don't need to really work on it, at least like at first. So, but one thing important is that this name, speed, is actually the one that is used inside the code. So if you change, I don't know, speedo, then this won't compile. I'll avoid it because it's going to do this flickering thing. And if you decide to change the name, you also have to like refer to that name inside GLSL code. So this would work fine. Although I just changed the name, so it doesn't really change anything. And type float, there's also another type, which is, for example, if you look into like modulate family, it takes well, actually, it doesn't take the like different kind of type because it's kind of implied when you're using, well, this is like already spoiler, but this combine chord, for example, or blending functions use type called combine, which is not type blend, but it's called type combine. It's confusing. It's not type modulate, but it's type combine chord. For I guess it's more like historical reasons. But they imply that the first parameter or first input is another function or texture. So there is no like type texture to this. So it's kind of like implied, and you don't really need to do it that way. But also there's a special type called sampler 2D, which is in the case of like source. Again, the confusing one that has like name, source, type, source. But this is what I'm talking about source here is like what do you do, like src0, like this kind of source function. This takes specifically because we're talking like just like a family of source, like gradient that we were just looking at, Voronoi. So they always take numbers, but this one exception is this one. It's called src function, which takes a sampler 2D as an input, and this sampler 2D can be referred to as text, like texture, I guess, in this GLSL code. But this is like really like exception, so I'm not gonna like talk too much. I actually don't know much about it. Normally we have float type. That's something like if you want to like create inputs, that's normally float, and the name is really like what you like, and always put the default parameter that like if you the user omits that parameter or input, then it will take the default. Okay, so but I can actually just like delete this part because it's a little bit like this problem with this like defining set function inside editor becomes like lengthy. So I try to like, if I'm like working for my project, I might actually delete some of these like new lines, which it's like compresses the code a lot. So I do that. Also like inputs, like if I keep one of these inputs, I might just like, you know, delete all these white spaces. Right, maybe I just do it like this so that if I want to come back to inputs, I can still work on it. So something like this is good, right? Okay, so we keep the input and we keep it as speedo, although I'm not going to use it because I'll just like try to simplify this. So inside GLSL here, that's, or the GLSL parameter of this object is a string, and that is the GLSL code itself. And the convention for GLSL code is like depends on the type you're like setting. So this source family or type or family, like source, they're different from how like the convention is here is completely different from geometry or what is called chord as a type, blending, which is combine. They all have like very different conventions. So that's something we really need to know if we want to create our custom functions. But don't worry, you can always just, you know, you don't have to like type this by heart. You don't have to remember by heart, but which I always don't do. Which I do is just go to this GLSL functions JS that is used by Hydra and just take one that I feel I want to like customize, and I'll change things so that I don't have to like remember every time what I have to do, because it's very confusing, and I think nobody, like even Olivia, probably doesn't really remember. I don't know, maybe she remembers. Sorry Olivia. But anyways, so okay, let's change something that is a bit more exciting, because I spent like 20 minutes already and really haven't made anything just beyond basic gradient. So let's take a look, and I'll just like keep this a bit more verbose. So if you're already familiar with GLSL, what ST does is it's going to be like unwrapped. And even if you know GLSL, probably you might not know what this underscore ST is. And this is the convention that I'm talking about. So underscore ST is something given inside Hydra, which is the coordinate of the pixel, basically. So in the case of type source or the source family, what is given is which position we're talking about, because that's the only thing that the source function is dependent on. Like, it doesn't take anything from other functions, right? It doesn't come after other functions. It's just like standalone thing, but just give me which XY we're talking about, because the color here is different from color here is different from color there. So it's always dependent on the XY position, and that's the only thing that the gradient or the source family needs. And this time, this is like something more like a global value, just like how time works in Hydra. Time, not as a concept, but the parameter time, you can use it inside Hydra. It's also passed to GLSL. And for example, like if you have gradient with the parameter 1, or now we're gradient 2, but it's okay. This parameter changes like the blue channel, and that's why this is what is happening under the hood. So the red channel is just the X position, green channel is the Y position, and the blue channel comes from sine time times speed, or now we're renamed it to speedo, but it doesn't really matter. And basically this is the sine wave. And you can actually know that it is not normalized. Like normalized version is like this, but it's not normalized. So actually the blue channel goes negative value and shoots up to 0 past, and then 1, 0, minus 1, 0, 1. It goes this cycle. So you actually see more time with this part that is like this classic gradient for a second or a few seconds, and then goes to this bluish tint and then comes back. So if I don't want this, but if I want like this to be like always like blue, I can just take this out, say 1.0. If you do this, now I took the speed parameter out, so it doesn't really matter whatever input you put. Well, it will be like processed by the function gradient 2, but it's not affecting GLSL anymore because there's no speedo parameter in here. And basically what it does is like, maybe like this kind of gradient is familiar to some of you if you work with, I don't know, other kind of shader. This is like, now it's just taking XY position for RNG, but instead of like taking the blue channel to 0 or like oscillating, it always be 1.0. So it has always this kind of bluish tint, and alpha channel is also 1.0. Is this exciting? I mean, it's kind of cool that now I can like individually change the blue channel. Like if I want like 0.5, okay, that's kind of maybe nicer. 0.6, I can like adjust it, which is quite nice. But also something I really want to like emphasize here is that there's nothing wrong what I'm doing here, and it's like more like for learning. I think it's really important that you start to like edit parameters and see what can happen. You also don't have to like put this SD X and Y, right? So you can just do it like this as well. It's the same. That's how this vectors work, or like unwrapped. How is it called? There's a word for it, but I forgot. Inside GLSL. But for illustration, I think this is clearer. So that now it's like red channel, green channel, blue channel, and alpha channel. And again, also like if I don't want sine wave, but like I want cosine wave with time times speedo, and I also want to like normalize it. This kind of thing is like possible. Well, I didn't add the speed here. So you can start like create your own shader, but with like actually like quite a lot of constraint. That, for example, you cannot cannot really have like other inputs here. It's also like purely dependent on X and Y. You cannot have like feedback in itself. So you have to like start to like think about the design of this function combined with other functions. And this is like what it gets really tricky. And also what I want to say here is that if I say like, okay, I like this texture, so maybe this is the function I want, but also you can make something like this with gradient. So I'm just gonna like use like standard Hydra without any set function. If you just wanted that exact texture, you can do something like add solid 001. So I'm just adding a solid texture with just with the blue channel, and this is gonna be the same. So it's not always the case. It's not always that you can recreate something with existing functions in Hydra, but sometimes if you just like step back, think about it, maybe you can do something with just with like normal Hydra functions, like combination of Hydra functions. And this is, I think it's really interesting, like exercise to do. For example, like I can make something, okay, I just want to make like my version of OSC. So as we saw, like probably like creating OSC with this is quite simple. Well, I'll stick to this like gradient too, which is kind of weird name if I want to make OSC. But for example, if I say sine of this, I guess this is already pretty much like OSC, and you can just like, you know, copy and paste 3 times, or if you want to do it like GLSL way, you can do vec3, and okay, this is not enough, maybe I'll add frequency, like, okay, times 60, and oh, it's not doing it. I don't know why. Oh, because it's like 60.0. Okay, so this is already almost like OSC, and I think it's just a normalization problem. So I can recreate OSC, and then I just have to probably add time to it, and it moves. I probably need to add this like sync or speed parameter, or maybe I can use just recycle this speedo parameter. Yeah. So now what I'm doing here is, okay, like this, maybe a bit faster. I don't know why it's a bit slower, but now I recreated OSC, although I cannot make this, how to say, the phase shifting, like color shifting at the moment, but I can create something like this. That's great. And you can actually, so this is like backwards now. Now I'm like trying to recreate what is inside Hydra instead of like doing the other way around. I made some function that I tried to make it with existing Hydra functions. So this kind of like goes both ways. And it's really about learning at this point, like not really like inventing something new, but reinventing the wheel. But I would say like reinventing the wheel is also like really good strategy for learning. So I highly encourage you to try out. How does OSC work? And can I create it with setFunction on your own, starting from gradient, for example? I'm gonna just like stop the movement for now. And also, like if I like to make it more like a circular OSC, if you're familiar with GLSL, I would say, and maybe I can add, like introduce a parameter here. I don't know if it's called, is it float? Yeah, it's float. So you can like define your own variables as well. And R is length of ST. So instead of like using ST as like position, like XY position, I can make length, so like length from the center. And here I would say, okay, I'll just say this is R instead. And what's going to happen is I can make something like this. And this is actually quite interesting, like surprise to me, because I didn't add like this one. This will make it from the center, but if I don't do it, length ST, because it's the screen coordinate, it goes from 0 to 1 instead of minus 0.5 to 0.5 or minus 1 to 1. So if you take this, then the center of the coordinate is this side, right? Yeah, left top instead of the center. And this is like different from how you would do OSC Kaleido with, I don't know, 999 or something. This is something similar, but I mean, I can also stop the movement. This comes from the center, and if I really want to do something like this with top left, is it possible? Not very straightforward, because if you do scroll, it makes this repeated pattern. So I think I already explained in some of the videos, I think it's not really clear what it was happening. But for example, if I do like solid 0.5, 0.5 with modulate, then you can create the same like visual effect or result, but it's a little bit lengthy and it's also like really like weird what is happening. And if you think that GLSL way is easier to understand for you, then, well, I evaluated this. Oops, doesn't really change the speed. Okay, so yeah, it's a little bit funny, but yeah, so I would say like this is like, I'll keep this as a comment as a Hydra only, like default Hydra counterpart. But for example, if you find this GLSL code to be more understandable, maybe you can use this. I mean, there's nothing that stops you from using this one. So it's really like a choice. And also like, it's always like interesting to go back and forth to understand what this setFunction like GLSL does versus like how it's compiled in the like default Hydra functions. And I think this like is interesting interplay that you can like play with. And I took quite a long time in this video, but in the next video I promise that I will go through other families of functions like geometry, color, blend, modulate, which are like again named as different names and type of the object. But I will go through one by one and try to create different examples with it. So thank you for watching, and I hope this was useful to some of you. If you create something interesting, please share it in the comment down below or other online communities of Hydra and live coding. And if you have questions, also like please let me know. And otherwise, happy coding, and I will see you in the next video. Bye.